Okay, we're talking about applications with logs. We're still looking at those same 4 formulas like what we did before. So let's write those just to remind ourselves. So remember, if your problem is talking about growth, so maybe population or even the value of something or whatever, you want to use the formula y equals a 1 plus r to the t. And then if you're looking at decay, the formula is the same except you do 1 minus r. So y equals a 1 minus r to the t. And then the other two are when you're talking about money that is compounding. So the first one is if it's compounding maybe quarterly or monthly, etc. Okay, so anything but continuously. And so remember that formula is A equals P 1 plus R over N to the NT. And then the last one is if it's compounding continuously. So that one, A equals P E to the RT. Remember, E is the number E, it's not a variable. Okay. So when you're setting up these problems, what we were doing before is we were always finding how much we had at the end. So we were either finding Y or big A. Today we're going to be looking for either R or T. Okay, so we're going to know how much we have at the end, and we're going to want to know how long is it going to take us to get there, or at what rate did it grow or decay for us to get there. So you still set them up the same way. You figure out which equation to use, plug in what you know, and then you solve for the variable. So let's do one. And these are word problems, so bear with me. So our first one says, suppose a graduating class had 500 students the first year. But after that, the number of students declines by 10.6% per year. So we want to know in about how many years will there be 300 students graduating. Bless you. So which formula do we want to use? Decay. How do we know it's decay? So right here it tells us it declines. So it is decaying. So if I look at this, y is how many students we're going to have at the end. A is how many students we started with, and then our rate and our time. What are we trying to find? Which variable are we looking for? Time. Good. Because it says how many years. So we don't know t. That's what we're going to be solving for. So y is how many we have after this amount of years. And how many students is that? 300. Good. So 300 equals how many we start with? 500. 1 minus, and then remember we want our rate as a decimal, so 0.106, and then we don't know t, that's what we're trying to find. Bless you. Okay, so now it's just a regular old exponential like what we've been solving. So we want to get the exponential term by itself. So I need to get rid of that 500. How can I do that? Close. Divide. Good, because it's 500 times this. So divide both sides by 500. Which will get rid of that. And then 300 divided by 500 is 0.6. And then inside our parentheses here, we can go ahead and subtract that. So I can go ahead and say 1 minus 0.106, and I get 0.984. Or sorry, 0.894. Sorry, flipped it. To the t. So 0.894 to the t. Any questions getting here? So now we want to change it to log form. We haven't changed it to log form where the exponential has been on the right. So if you want to switch it, you can. So I'm just going to make this 0.894 to the t equals 0.6. And that's just how we've been used to seeing it. You don't have to change it that way, but that's what we've been doing. So now if we make it into a log, our base is that 0.894. So log of 0.894 of 0.6 equals t. So you still change it the same way, we just have decimals now. And now we type it in. And so we get about 4.56. And we're talking about time, so what's my units? Good, years. Good, good, good. Any questions on that? Alright, let's look at another one. So this one says Jane really wants to buy a car. She needs a down payment of $4,000. If she deposits $3,500, into an account, compounding continuously, at a rate of 3%, how many years will it take her to save enough money to buy the car? Okay, so which formula should I use? Yeah, so the one that's compounding continuously. Good. So A equals PE to the RT. Which variable am I going to want to solve for? T, yeah, because I want to know how many years. So that is time. Good. So A is how much money she needs after this amount of time. So how much money does she need? 4,000. Good. How much does she start with? Good. And remember, E is E, the number E, not a variable. And then our rate as a decimal, good, 0.03 T. Because we don't know T, that's what we need to find. So then, in this one, we want to get E by itself. So how can I move that 3,500? Good. Divide by 3,500. And then that's a pretty good decimal, so I'm going to leave it 8/7. So if you divide it, oh, nope. And then you can say math, enter, and it'll make it a nice little fraction for us. Then, again, if you want to put your exponential over here, you can, so I'm going to switch it. You don't have to switch it, though, if you're okay changing it from a log when it's on the other side. And then what kind of log do I make an E? Good. So make it a natural log, so ln, and then 8/7 equals our exponent, which is 0.03 T. Good. So then we want to get T by itself, so we divide. So then ln of 8/7 is about 1.33 divided by 0.03 gives us about 4.45. And again, we're still looking at years. Questions? Alright, let's do one more. So this one says if the population in a state was 3 million, and 10 years later, it was 14 million. By what percentage did it grow each year? So which formula should we use? Growth. How do we know it's growing? Yeah, so it's going up. It says grow. So y is how many, what are we trying to find? Percentage. So we want to solve for r. Okay, so we know everything except r. So y is how many we have at the end of this 10 years. How many are there at the end of 10 years? Yeah, 14. So 14 equals, what was the population to start with? 3. And it's growing, so 1 plus r. And then we're looking at 10 years later. Right. So first we want to get this parentheses and 10, all that by itself. So how can I move the 3? Good, divide. And then 14 thirds is repeating, so I'm just going to leave it 14 over 3. Equals 1 plus r to the 10th. How do I get rid of a 10th power? Good. So we want to 10th root it. Good. So then that gets rid of that 10. So we just have 1 plus r over there on the right. And then to type that 10th root in the calculator, you have to type the 10 first. And then you go to math under your green button. And then you look at number 5. And then it'll automatically put the little 10 up there for you. Okay. So again, we go 10, math, number 5. And then 14 thirds. So we get about 1.167. And then what would be my last step? Good. Subtract 1. So 0.167 equals r. So what percentage is it growing? You got it. 16.7%. Questions?